the function, and also I'm going to just look at them through arrow diagrams. Later on, we're going to define a function by actually giving let's say, giving an algebraic implementation of it. Okay, so let's have a look at another diagram. So let's say consider the arrow diagram. Okay, so we have another arrow diagram. Okay, so what I have is I have the set A, okay, I have the set B, okay, the set A contains values 1, 2, let's just say there's 4 values in the set A, and the set B contains 1, 2, 3, 4, contains 5 values. And we know for this function, let's call it f, okay, for f is a mapping. F is a mapping from the set A into the set B, okay? So it's a mapping from the set A into set B. First of all, for it to be a function, every value in A needs to be taken to some value in B, okay? That's one condition. So every value in A needs to be taken to a value in B. So let's just do it like this, okay? Let's just say like this. So here we go. And let's say this one here is taken to here. So clearly every value in A is taken to a value in B. Okay, that's the first condition for it to be a valid function. And the second condition is this: is that we can never have two edges or two arrows leaving a single point here and going to separate points over here. Okay, in other words, if I was to give you an example of not a function, okay, something that's not a function, okay, we have something like this. And we have something like this, and maybe let me just put in another value. Okay, we have this goes here, this goes here, let's say this goes here, okay, and now I also have that this goes here. Okay, this is not a function because the second condition associated with a function is not satisfied. We have two A's, okay, we have two A's here in this set A, okay, that are taken to two separate values, okay. So by definition, that's not a function. So we never have two arrows going out, okay. But the question we really want to ask is f surjective? Is this function surjective? Okay, that's a question. Now, for this function to be surjective, if you look at the definition again, okay, what we're saying is that every element of B, every element of the codomain, okay, every element in the codomain, okay, for every element in B, that's the codomain, there exists at least one element in A, okay, such that when we pass the element in A into the function f, it's taken to a value, the value in B, okay. In other words, every element in B has an incoming arrow into it, at least one incoming arrow. Okay, so if we look at this particular function here, okay, we can see that, well, it is a function, okay, because every value in A is mapped into B, and also we don't have double arrows leaving any points over here in A. Okay, so it is a function. But is it surjective? Well, we don't have every value, this particular value here, okay, this particular B value, okay, there's no A value that's mapped into it, okay, so we can never find a value in A that's mapped into it. So actually this function by definition is not surjective. It's not a surjective function, okay. Let's have a look at another example, okay, let's consider, okay, so let's say this is example 2, let's say example 3, let's consider, okay, let's consider the following function, okay? The following function, okay? Okay? Let's just say, for argument's sake, that we say let A equal the set 1, 2, 3, and 4, and B equal the set. Let's say for argument's sake we have A, B, C, D, and E. Okay, just say for argument's sake, okay, and let f be a function that takes values in A into values in B. Okay, and it's defined by the following arrow diagram. Okay, so what we have is we have the set A is here. Okay, so this is the set A. Okay, we have the set B is here. Okay, this is the set B. A contains the values 1, 2, 3, and 4, and B contains the values A, B, C, D, and E, okay, and E. And what we're going to do is 1 is going to get mapped into A, 2 is going to get mapped into A, 3 is going to get mapped into A, and 4 is going to get, let's say, mapped into B. Okay. The question is this function surjective? Well, for the function to be surjective, every value in B, every value in the codomain, okay, must have an arrow coming into it. In other words, some value, for every value in B, okay, there must exist some value in the domain that when we pass that particular value into the function f, it's taken to the value in the codomain. So in this case here, this is not surjective, if that makes sense. Okay, so it's not surjective. Okay. Some other maybe examples that we could consider. Okay, let's say we consider the following function. Okay, let me make it a little bit more, let's say, not complicated, but let's a little bit more more probably abstract. Okay, let's say let b equal to set 2 minus 2. Okay, and a equal to set, well, doesn't let b equal this, and let f be a mapping from the integers into the set b. Okay, defined by, okay, let's say it's defined by f of x, okay, is equal to, okay, well, f of x is equal to 2 if x